How would your life change if you could suddenly see radio waves dancing off your Wi-Fi router, or the ultraviolet patterns hidden on a butterfly's wings, or the infrared heat signature of the person sitting next to you? What if you could look up and see cosmic rays streaming through the atmosphere, or glance at your microwave and witness the electromagnetic waves cooking your food from the inside out? It might sound like a superpower, but the truth is, if all humans suddenly gained the ability to see the entire electromagnetic spectrum overnight, we'd be in for a shock. And no, I'm not talking shock like being amazed by beautiful auroras or fascinated by the glow of our electronic devices. I'm talking about society grinding to a halt, mass confusion and panic in the streets, and our brains potentially shutting down from sensory overload. But at the same time, our limited vision doesn't seem to be doing us any favors either. We're missing out on 99.9999% of the information that's constantly flowing all around us. From the cosmic microwave background radiation left over from the Big Bang, to the radio signals bouncing between cell towers, to the X-rays passing through our bodies, there's an entire invisible universe that we're completely blind to. So it begs the question, if humans could suddenly see the entire electromagnetic spectrum, would it unlock new potential for scientific discovery and understanding? Or would it plunge us into chaos as our minds struggle to process this overwhelming flood of new information? Clearly we have a complicated relationship with our limited vision. Today we use technology more than ever in night vision goggles, thermal imaging cameras, radio telescopes, X-ray machines, you name it. But the problem isn't how much we extend our vision, it's that we haven't figured out how to process all that information without technology as a filter. We've poured tons of money into building devices that can detect different wavelengths, analyze them, and present the data in ways our brains can understand. But there's never been the same kind of investment into how our brains would handle that raw information directly. Now, you might think, I'd love to see all wavelengths, wouldn't that be cool? Yeah, well, no, not exactly. Seeing the electromagnetic spectrum isn't as straightforward as it seems. Let's take a closer look at what your eyes actually do. In your retina, you have specialized cells called rods and cones. Rods help you see in low light, while cones detect color. Humans typically have 3 types of cones, each sensitive to different wavelengths: red, green, and blue. Our eyes can only detect wavelengths between roughly 380 to 700 nanometers, what we call visible light. That's just a tiny fraction of the entire electromagnetic spectrum. And there's a good reason for that. Our eyes evolved to detect the most useful wavelengths for our survival, the ones that the sun emits most strongly and that aren't absorbed by our atmosphere. Different wavelengths have different energy levels too. Radio waves have long wavelengths and low energy, while gamma rays have extremely short wavelengths and high energy. If your eyes could suddenly detect gamma rays, they might be damaged by the very radiation they're sensing. So because of these limitations, only certain wavelengths can be safely and usefully detected by our eyes, while the rest requires specialized equipment to measure and translate into something we can understand. The good news is that there's actually a solution to these limitations, and it's not just a distant dream. It's technology and adaptation that's already taking shape. But we'll get to that later in the video. First, let's look at one of the more dramatic scenarios that's been contemplated. What if we just gained the ability to see everything all at once? Well, as we discussed at the beginning of this video, that might be one of those ideas where you should be careful what you wish for. Imagine waking up one morning and something feels off. Well, your bedroom is filled with pulsating waves of energy. Your phone on the nightstand is glowing with radio frequencies, while your body and bed radiate infrared heat signatures. Confused, you look out the window only to see the air itself is alive with radiation. UV rays are streaming through clouds, radio waves are bouncing between buildings, and cosmic rays are shooting from the sky. And that's just the beginning. Your neighborhood is a cacophony of light. Cell towers are blazing beacons, power lines are surrounded by electromagnetic halos, and every electronic device is surrounded by its own unique pattern of radiation. Panic sets in as you look around. Your vision is overloaded with layers upon layers of information. Visible light mixed with radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. Your brain, never evolved to process this much visual data, struggles to make sense of anything. You can't distinguish between what's important and what's background. Is that glow coming from your coffee maker harmless? Or is it a sign of danger? In hospitals, total chaos. Patients and doctors alike are overwhelmed by the visual noise, unable to focus on what matters. Looks like we've been thrown into a perceptual nightmare, a reality most of us aren't equipped to handle. You see, without filters and processing, this expanded vision isn't just overwhelming, it's potentially crippling. So, maybe gaining all this vision at once isn't the answer. What if we didn't have to choose between our limited natural vision and being overwhelmed by the full spectrum? Some serious cutting-edge solutions are being developed right now that could give us the best of both worlds. And one of the leaders in this game-changing tech is the field of augmented reality. Let's take a look at how it's evolving. Say hello to advanced AR systems. They're tackling the information overload problem head-on with sophisticated filtering and processing. Unlike our natural vision, which just takes in raw light, Arkansas takes it to the next level. It's a type of technological interface that can show us different parts of the spectrum when and how we need them. Here's how it works. Scene 9, sensors and AI. First, specialized sensors detect different wavelengths across the spectrum. This data is processed by AI algorithms that determine what's relevant based on context. The system then overlays this information onto your normal vision, showing you only what's useful in the moment. What comes out? A customized view of reality that enhances your perception without overwhelming it. Their systems use sophisticated eye tracking and brain-computer interfaces to determine what you're focusing on and what information you need. This means less cognitive load and more intuitive understanding. But it also tackles a deeper issue. Most of our current technologies that detect non-visible wavelengths require expertise to interpret. These are specialized tools that only scientists and technicians can use effectively. By making this information accessible and intuitive, Arkansas systems help democratize our understanding of the full electromagnetic spectrum, allowing anyone to see radio waves or infrared signatures when needed. This technology isn't just showing us more, it's rethinking how we perceive reality. It's all about creating an enhanced experience where our vision isn't just expanded but optimized for human understanding. I know you're thinking, if this technology is so great, well, why isn't it a household name? Well, after decades of research and development, the technology is currently maturing and moving beyond clunky prototypes. With advances in miniaturization, AI, and brain-computer interfaces, we're getting closer to seamless integration with our natural vision. With continued development, this tech could totally change how we interact with the invisible world around us. Okay, so what's the takeaway here? Just because we can't naturally perceive something doesn't mean we should jump straight to having all that perception at once, because that could create even bigger problems. Let's keep that in mind before wishing for other sensory superpowers, like the ability to hear all frequencies. Can you imagine hearing dog whistles, bat echolocation, and elephant infrasound all at once, maybe